If you're at home, you can pause this and check the solutions to your homework. Just wanted to make sure that you saw those. All right, let's get started. Okay, today the learning target's the same. I can graph linear equations. Okay. So before we get started on graphing linear equations, because we're definitely going to look at some that the line looks slightly different, I want to just go over your vocabulary real quick. When we had proportional relationships, you guys got very used to the equation y equals kx. Okay. Well, with linear equations, proportional relationships are actually they are linear equations, but they're special linear equations because they go through the origin. So, but not all linear equations do that. Okay, sometimes they do, but for the most part they don't. So we can't use k as that variable in front of x. So we're actually going to change the name of it. Okay, and we're going to go over this in a lot of detail next week, because this week we were focusing on how to graph using input-output. Next week we're going to focus on how to use these numbers. This is going to be called the slope, and this is going to be called the y-intercept. I'm going to show you how to graph that way because it is a lot faster. Okay, but for today we're going to stick with the input-output, and I just want to make sure that we remember that x is your input. Okay, your y is your output, which makes a lot of sense because you pick numbers for x to be, you put them in, so they're the input, and what you get out is your y, which is your output. Okay, so it's very logical. These also have another name, and we'll dive into these other names in more depth as we get to different units, but I'm just going to give you the names for right now. And we also call the x the independent variable. And we call the y the dependent variable. And this also has a very logical reason for calling it these things. Your y always depends on what your x is. Your x can be anything. You can plug in anything for x. And then your y it just depends on what your x is. So that's why this one is called the dependent variable, because it depends on whatever your x is. And your x is your independent variable because they can do whatever they want. You can put anything you want in for x, and then it's your y that changes accordingly. Okay? And I was laying in bed last night and I was thinking of like a funny comic or something, like where x is sitting there going, I can do whatever I want. I'm totally independent. And then the y goes, ugh, I always have to depend on x. And that would be funny, but maybe not. All right, so it's math teacher humor, sorry. You could humor me. Macy thankfully gave me like a little chuckle and a smile, so. All right, so these are ways that we can describe your x and your y. And we'll use them interchangeably, and we'll use them depending on the situation too. Another thing too that I drew up here for you is equations are like machines. okay? So in like a machine shop or something like that, you would put a material in, it would do some things to it, and then you'd get a product out, okay? That's kind of what's happening with an equation. You put in a value for x into the machine. Here's the equation. It's going to do something to it. So in this case, it's going to multiply it by -2 and add 5. And then out comes your y. Okay, so equations are like that. They're like a machine. In and out. All right? So what we're going to do now that we've kind of talked a little bit about that vocabulary and how equations work, I just want to go over a few examples that are just taking another spin on linear equations. All right. You'll notice that on your homework from last night and all the problems that we did yesterday, your lines were going up in that same direction. Sometimes they were a little steeper and not quite as steep, but they were all going up, okay? I'm going to give you an example where that is not the case. You can see what that looks like. All right. And we're also going to simplify that chart too, that input-output chart, because there's some rhetorical stuff in there. There's some things that you just don't need to keep writing. So let's go ahead and set this up. We have x, which is our input. We're going to plug it into this right here, into our equation. And then we're going to get y out. Now, in the other charts that we did yesterday, we listed the ordered pairs. But really, your ordered pairs are just your x and your y. And there's really not a reason to write those down again. So I'm going to skip that step, and you're welcome to as well. All right, so let's go ahead and put in some numbers here. We're also going to be talking about what to put in for x, because you'll notice on your homework tonight, I did not give you your x values to plug in. You're going to pick them. And usually, and if you're stuck and you don't know what to pick, my go-to is always 1, 0, -1. Because that way you have one positive, you have that 0, and then you have that negative, and so it gives you a good picture of what that line's going to look like. It also keeps it right there in the center of your graph, and it's so much easier to graph that. Because technically, you could put in anything for x to graph your line. But if you plugged in 100 for x, your graph is going to be huge, because then you're going to have a graph that literally goes 100 spaces over. So if we keep those things nice and small and near the origin, it just makes graphing a lot easier for you guys, okay? So that's what I'm going to do. And I'll show you some cases where you may want to change this, but your go-to, my go-to is always 1, 0, -1, okay? So I'm going to plug in +1. -1 minus 3 is -4. And then I'm going to plug in 0 here. Okay, so that's going to be -3. It's going to be +1, because remember, a negative of a negative is a positive. So 1 minus 3 is going to be -2. Now, this is where you would have listed your ordered pairs, but really that's just this. 1, -4, 0, -3, -1, -2. Yeah, Elizabeth?
Why did you put -0?
I was just plugging it in to the equation. See, the equation is -x minus 3, and if I have x be 0, I just plugged it in. But -0 is just 0. All right, so let's go ahead and graph this now. I'm gonna, I think I'm gonna zoom in a little bit on this, but let me put my coordinate plane up here first. Okay. So let's see here. This first point is 1, -4. That second point is 0, -3. And that third point is -1, -2. And then I can connect it to make a line. And I know we talked about it a little bit yesterday, but we also kind of ran out of time, so I'm going to put a little note here. This line, it represents all the solutions. So it represents all the solutions to this linear equation. Because check it out, if I just, you see that it's crossing exactly at 2, -5. And watch, if I plug in 2 here, I'm going to get -5. So it literally is every single possible combination of ordered pairs that will make this equation true. Even the crazy ones, like if I were to pick one random spot and it's decimals, it would still work. Anything on that line is going to work, okay? All right, so let me show you, now I want to show you an example where you have a fraction so that you can see how to tackle that. I probably made that bigger than I needed to, but that's okay. Okay. Again, I'm just going to stick with my tried and true 1, 0, -1 for that. Did you have a question?
No, I just asked you to put it down.
Okay. Silence your phones, please. Okay. So I'm going to plug in all of these x values, and then we can see what we get for our outputs, our y values. Okay. So 2 times 1 is 2. 2 minus a half is going to be 1 1/2. Okay. This is 0. 0 minus a half is going to be -1/2. And then 2 times -1 is -2. -2 minus a half is -2 1/2. Okay. So, you know, it's the same deal that we've been doing, but you just get fractional answers for, or you're going to get y's that are fractions, which is totally fine. We got this. Now you have a couple options now when you graph it. You can just keep all of the units, each square being 1 unit, or you can change the scale. So I'm gonna do it keeping it 1 unit just so you can see what that looks like. In my last class, I asked them if they wanted me to show them what it looks like changing the scale, and they were like, no, we're good with 1 unit. So you guys can decide. Okay, so my first point is 1 and 1 1/2. So I'm going my x is 1, and then my y is 1 1/2, so I'm going to go to 1 and halfway. Okay. My next one is 0 and -1/2. So I'm not going to go to the left or right because x is 0, but I am going to go down just a half in the negative direction. And then my last point is -1 and 2 1/2. And it looks like this. And now I can connect it to make a line. So that's what it looks like if I don't change the scale at all. I just am going to be graphing halves, and that's fine. Do you want me to show you what it looks like if we change the scale? Sure. Okay. Well, darn, I don't really have a whole lot of space, but that's okay. We'll make it happen. I'm going to do it down here. Hopefully I have enough space. I may or may not. Okay, so when you change the scale, you do need to mark your new scale. So what we're saying then is that each unit is a half. So this would be 1, 2, -1, -2. And then this will be -1, -2, -3. And this will be +1, and so on. And then I'm gonna go through and graph my points. So then your 1 is here, your y is 1.5. So I'm gonna go up to 1.5. And then 0 and -0.5. And then -1 and 2.5. You're gonna see that the line looks exactly the same. It's just the scale that's kind of zoomed in a little bit. Does that make sense? Yeah, Elizabeth.
On the, not the orange little thing, but the blue one, how did you get -2.5? Like, what did you do to, find the dot?
For this one?
No, the other one.
This one?
Yeah.
I just went down 2.5.
But how come you didn't do it on the line? Why'd you move 1 over?
Because my x is -1. So I went -1 on my x, and then my y is -2.5.
Oh,
Does that make sense?
yeah.
Okay, good. Anybody else have any questions? You guys are good? All right. Let's go ahead. I'm going to give you one to practice, and this is going to give us also a chance to talk about sometimes you might want to change what you plug in for x. Let me flip this over. Okay, so this is y is equal to 1/2 x minus 7. Now, sorry, that was way up there. If you were to just plug in your usual -1, 0, and 1, you're going to be graphing fractions, which is totally fine because we just did it on the last problem. But if you want to make your life easier, you can choose to change what you put in for x. And let me show you. Okay. If you choose to change it, you could put in, yeah, Maddie.
Is that a 7 or a 1 when you say x minus?
It's a 7, sorry.
Oh, okay.
If you were to put in, instead of putting 1, if you put in things that are divisible by 2, because this is a half, then it will make your problem solving and graphing a little bit easier. So in this case, I would probably change this to -2, 0, and 2. And then when I plug in and solve it, it's going to be so much simpler. Your answers are going to be whole numbers instead of fractions, okay? So let me go ahead and do this. So this is -1 minus 7, so this is going to be -8. Oh, you guys are supposed to be doing this one. Go ahead. Carry on. Finish it up and graph it. I'm gonna put a little note here. And I do want to say, if you plugged in -1, 0, and 1, it totally would have worked. You just would have been graphing fractions. But sometimes it's nice to give yourself a little break and just say, oh, I don't feel like graphing fractions today, and make them whole numbers by plugging in things that are divisible by 2 for x. And if this had been 1/3, you'd probably want to plug in -3, 0, and 3, because then they're divisible by 3. So it just depends on your equation what you choose for x. But really, always -1, 0, and 1 will work. It's just a matter of whether or not you want to graph fractions. Okay, I'm going to start working on this while you guys are working on this so we can check and see how you're doing. This is -2, -8. All right. How'd it go, you guys? Good? Does anybody have any questions about this? Yeah, Sienna. Yes, I can put the table of contents up. If there's no questions, you guys can go ahead and get started. I try to leave you guys time to get your homework done in class so that you wouldn't have any over the weekend. So I'll put the table of contents up and you guys can just work. If you're at home, you can pause that and write it down.